Well, welcome everyone. We are thrilled that you're here to learn about how to apply strong data protection controls to protect your highly regulated workloads. I'm Elo, one of the security product managers responsible for talking about data protection, whether it's ranging from topics of post-quantum cryptography to privacy-enhancing technologies like confidential computing. I'm excited to be here with you today, and I'm here with my colleague, Simon.
Hey, good morning, everyone. My name is Simon Bennett. I'm a product manager in the infrastructure teams at Google Cloud. I focus on Compute Engine and GKE. Thanks, Elo. What we're going to be focused on today is how to run your high-stakes workloads on Google Cloud without compromising control over your data and your services. We're going to be showing you how to protect your IP with hardware-rooted, trusted execution environments, and how to avoid manual remediation and catch-up tasks through automated policy controls and developer guardrails. We're going to do things a little bit different. It wasn't just the walk-up music. We're going to give you a little peek behind the curtain. Google works very hard to earn your trust, the opportunity to run your workloads and store your data. And some of our unique hardware designs are how we go about protecting that data. But there's a challenge. Getting into a Google data center is incredibly hard. Most Googlers, including us, will never step foot in a production facility. So instead of trying to bring all of you to a Google data center, we're going to be bringing some of the hardware that our system is built on to you today. See, many of you have come to the front of the room. That's probably a good call. If there's folks at the back that want to move forward, you're interested in the hardware aspect, now would be a great time. Like last year, this is not just a theoretical talk, so we're going to get into a little bit of practice and do a live demo that's putting together some of the concepts that we cover in the first part. This approach comes with some risks. We affectionately use the term unscheduled learning. There may be some unscheduled learning by us today. If that happens, we appreciate your patience and a polite round of applause while we frantically make things work in the background. Here's the structure of the session. We're going to focus first on hardware, our secure by design hardware infrastructure. We're going to move into software controls. Hardware is great, but you have to be able to put it to work. So we'll be talking a little bit about data boundaries, custom policies, and what we see customers, the primitives that we expose to you as customers to protect your workloads and data. And then finally, we'll get into that demo section. Elo, over to you.
Thank you, Simon. Well, like Simon had mentioned, we're not even allowed into the data centers. So you're probably asking yourself, well, clearly this isn't a data center. So Elo, what kind of hardware are you going to be able to show for us today? Well, I'm glad you asked, because you're going to be in for a treat. We've brought in some hardware components that highlight the security features and capabilities of our custom-designed titanium infrastructure. And because of all of the hardware that we have, we're going to follow the data, as we say in security, to show how the data is protected as it's brought into the cloud, at rest, and while it's in use. So if you're ready, Simon, maybe we should get some of that hardware out. Now, the titanium offload processor for networking is, you can see that underneath some of the thermal glue that he's holding over there. The titanium offload processor for networking provides the cryptographic controls to help protect the confidentiality and integrity of your data as it traverses across Google Cloud's network, all by default. The titanium offload processor is part of several of our newer machine families. In fact, at the keynote, you may have heard about our announcement for the new C4N, or network-optimized machine family, because it uses multiple of those titanium offload processors. Now, what does that connect within our infrastructure? We wanted to highlight two pieces of hardware that helps with the data protection at rest. As you can see here, that Simon is bringing across our titanium offload processor for storage. As he rotates the assembly, you'll see how the offload card is integrated into the disk array. Everything is encrypted by default, and this is important because before any of that data lands onto that disk, it's going to be encrypted for you by default, such that if someone were to take a drive out, that it would not be useful for them unless they had the Titanium offload processor and those data encryption keys. And speaking about data encryption keys, what if you have regulatory requirements that need you to manage the keys yourself? To help with that, we brought in with us a hardware security module. The HSM assembly here helps protect your keys. They're sort of like the enclave within your phones that protects your biometric information. It provides one of 3 protection levels. The HSM is part of our cloud HSM managed service and provides the hardware protection level. We also have software protection level as well as external keys. One thing to note that's important is that for your application developers, they can simply change the level of protection without changing their application code to get the different levels of protection that are necessary. Now, you may have heard a little bit about hardware-rooted trusted execution environments. And what is that? The HSM here provides one of the key components to construct the cryptographic root to protect the privacy of your data. So now we've looked at how we protect your data in motion and at rest. So what does that look like for some of the controls that we have when your data is in use? Simon is going to pick up this behemoth of a card that seems to be as heavy and as large as a hippopotamus. But we'll see what that looks like. What he's holding is the latest TPU 8T for training, the exact ones that we saw from the keynote earlier. This is such an accomplishment for us that you can see Sundar is holding the TPUs. We have Amin hugging the TPUs. And because you are here, you're now part of the family. And you're seeing part of the select few people on this planet to be this close to our latest generation of TPUs. Not only can you use these TPUs, but some of our services also use these TPUs, like Vertex AI. What's important here from a security perspective is on the packaging there, you'll see the latest Calyptra RTM, or root of trust for measurement. That enforces a security perimeter on each silicon package. The Calyptra RTM provides the attestation and unique cryptographic identity. So was there anyone here that was our session from last year? I can't really see, but hopefully some people are raising their hands. If not, but that's OK. You may have remembered the Open Titan. The Open Titan, what's different from last year, I've been working on ensuring that we have post-quantum cryptography across our cloud services. This Open Titan now supports post-quantum cryptography. As a refresher, Open Titan keeps our machines from booting if they've been detected to be tampered. This particular Open Titan is the first commercially available, open-sourced root of trust to support post-quantum cryptography for secure boot. So as you can see, we have a whole array of hardware from our Titanium infrastructure where security is built into the silicon from the start based on real threat vectors. Now, we spent a lot of time going over the hardware to talk about how the data is protected in transit, at rest, and in use. And so now Simon is going to talk a little bit about another layer of controls.
Thank you, Elo. Most customers have regulatory or compliance needs regardless of which industry they're in. They could be in a heavily regulated industry themselves, typically banking, financial services, infrastructure, healthcare. But increasingly, we're seeing other customers and partners who are serving their customers in those industries. GCP provides a compliance by design solution called Data Boundaries by Assured Workloads. These are software-defined controls that are baked into our infrastructure and build on the hardware primitives that Elo showed us. Assured Workloads comes out of the box with a range of control packages. These are designed to make it easy to implement different standards in different parts of the world and different industries. The slide gives an overview of some of the major control packages that we offer, but they're all built on 4 different sets of controls. The first one is data residency. That controls where your data is stored at rest. You can select which regions and countries your data can be resident in and prevent it from moving outside of those locations. Some of these control packages include options for local support and operations. That's where a Google Cloud partner manages the delivery of support, provides operations, and maybe restricts the location or the nationality of personnel who are providing support services. We touched a little bit on keys from a hardware point of view. Key management is incredibly important. You have Google managed keys, customer managed keys, or external keys to choose from, depending on the type of data that you want to protect. All of these options are available in the control packages mentioned here. The final area is access control and access transparency. So sometimes administrative access is needed by Google or others for troubleshooting. So we provide solutions that give you audited logs, and any accesses that are required to support your systems will only happen under permitted, predefined conditions. Getting started with assured workloads is very, very simple. In the web console, you can set your controls at an entire organization level for an individual folder, collection of projects, or down at a project level. We've found, particularly for ISVs and folks who are providing services, the ability to have different control packages in different parts of their organization gives them tremendous flexibility. They can have one set of controls for maybe their dev and test environments, another set of controls for unregulated production end users, and maybe a third set of controls for end users, customers who are in a regulated industry. The key benefit of doing that on Google Cloud is you can manage the same infrastructure using the same tooling, regardless of the environment and the end customer that you're serving. We talked a little bit about compliance, but compliance is more than just technical controls. As we know, the regulatory landscape is quickly changing, and there are many local variations between industries and countries. This is an opportunity where working with a Google Cloud partner can really help you navigate those waters. One of the example partners we have is Devoteam. Devoteam is an award-winning advanced competency infrastructure partner for Google Cloud. I wanted to highlight Devoteam in particular because Jason, their CTO, is sitting in the audience here today. He'll be available afterwards if you'd like to connect with him. They have a wealth of experience serving the verticals that you can see on the slide here. We talked about compliance and achieving a baseline of controls, but typically organizations have additional controls that they want to layer on top. These can often be specific opinionations or best practices over and above the baseline controls. Google Cloud bakes in a series of advanced features, including custom org policies and tagging. This allows you to program those best practices into the Google Cloud platform itself. This is useful for a very broad set of use cases. For example, implementing security standards, preemptively preventing costs from running higher than you would expect, or making sure that the features that you need to implement your reliability and resiliency goals are followed throughout your organization. As an infrastructure product manager, I wanted to give you some infrastructure layer examples of the controls that we've seen folks implement. Making sure that sensitive ports are not accidentally exposed directly to the internet without an intermediate security solution, very common one. Mandating the use of specific or custom OS images with your best practices baked in. Requiring the use of confidential VMs to handle your most sensitive data. On the reliability side, Things like making sure that object versioning is enabled in GCS, or that appropriate storage classes are always used, are very common opinions that you can bake in. Because those opinions are baked into the platform and enforced by GCP, it doesn't matter whether your developers and your teams are manually configuring these things, using infrastructure as code, scripting to configure these resources. The custom org policy will always ensure that your opinions are enforced. On the cost side of things, we have an amazing array of workload-optimized infrastructure. Custom org policies can be used to make sure that your developers are directed towards smaller instance types, or the more appropriate instance types maybe in the dev environment, and they don't have to choose from a very wide array of instance types, new families that we're adding all the time. One of the other things we see pretty often is over-provisioning of storage, so putting some preemptive caps in place for things like disk size or high-performance storage is a very common practice. Custom org policies come with a great life cycle, so often folks are not starting from a greenfield environment. They have existing infrastructure, existing deployments. Custom org policies can be drafted and then run in simulation and dry run modes. This allows you to draft the policy, but run it in your production environment in warn mode. Warn mode is great because we don't always have complete visibility into what's going on in our environment. You can draft a policy, run it in audit or dry run mode to see if there are any violations, sometimes weekly processes, monthly processes. We don't always think about. Once you're comfortable that that org policy is not going to break a production service, you can flip that to enforcing mode. Last year, we went through this in a little bit more detail. The recording is online. Elo, maybe you could focus a little bit more on the data privacy side.
I would love to. Thank you, Simon. So one of the things I enjoy talking about are some of the privacy-enhancing technologies that we have within Google Cloud. One of the things that I'd like to highlight is confidential computing. It provides the confidentiality, integrity, and verifiability to make sure that your data is encrypted while it's in use by your application. We want to make sure that we're protecting against privileged cloud admins, so that way we can keep your sensitive data private. You might be processing things like PII or personally identifiable information like images of people's faces, maybe healthcare records, and things of that nature. And that's where confidential computing can help. We have an array of confidential computing capabilities in our portfolio. Starting at the bottom of the pyramid there, from an infrastructure foundational perspective, we support it on our AMD and Intel machine families, as well as our NVIDIA-based GPU capabilities. Then there's a service layer that helps provide confidential computing that you can optionally choose to enable, whether it's GKE, Dataproc, or Dataflow. And lastly, we have applications at that level to be able to help protect things within confidential space. And those particular use cases are for customers that are looking to help with secure collaboration or maybe creating a confidential data clean room. For us today within our demo, we are going to focus in on confidential GKE nodes. Now, it may seem a little bit tricky to configure confidential GKE nodes. You don't have to take a picture of this, because what we've done is we're going to provide you a little care package, a code lab, if you will, that will have a QR code that you can take a picture of. But we just wanted to show you what it looks like to be able to configure confidential GKE nodes. So now, just to summarize, we've looked at multiple layers of security, ranging from data boundaries to custom org policies, and lastly, confidential computing. I don't know about you, but I'm ready to start doing something and building something. So let me just get a little bit comfortable, and we'll kind of get started into the live demo section. So, are you ready?
Thanks, Elo. We wanted to do something a little bit different for our demo, and we took inspiration from a local landmark. The Hoover Dam was constructed nearby in 1931. And it was the first major construction site in the United States where the use of hard hats was required and provided by the construction companies. We thought this would be a fun way to bring some common sense into the Gemini era. So for our demo today, we're going to be building a live app that makes sure that our construction workers are safe and wearing their hard hats. We have some technical requirements as well. Since we're dealing with likenesses of human beings, and this might be a sensitive site, we want to make sure that all of our video frames and the analysis happens in the US, and all of the processing is rooted in some of the strong hardware-based controls. We showed you the hardware that backs that earlier. We also want to make sure that all of the data is protected by encryption keys that we control. And most importantly, we want to make sure that there's no credentials or secrets within our application code. We know that the threat landscape is changing out there, and the keeping of long-lived credentials and secrets within our app is a best practice. Avoiding keeping credentials and secrets in our application is one of our design goals. Here's how we're going to go about doing that. For our first requirement, we're going to use our GCP location org policy. That's going to make sure that our application can be only deployed in data centers in the US. And this is a broad GCP level control. So the demo today will be using GCE, GKE, and the Vertex AI service, all of which are support the location control. To make sure that our data is secured and rooted in hardware-based controls, we're going to be making use of confidential GKE nodes and GKE shielded nodes. And we're going to be using CMEC to protect the data on our disk. In this example, we don't have a lot of data. Most of it will be kept in memory. So this is more of a defense in depth opportunity. We'll also be using Kubernetes service accounts to inherit permissions to call into the Vertex service. So let's start by deploying our application. Let me switch to the laptop, please. So I've pre-configured our GKE standard cluster here. I just want to give you a quick rundown. I've configured it to be a regional cluster spread across a few zones. And I'm just going to show you that we have enabled some of these control features. So down past networking here, you can see that we've enabled both shielding and confidential GKE nodes, in this case backed by AMD SEV. Deploying our application is pretty straightforward. I have a very simple deployment YAML file here, and really the only part which is different from deploying in any environment is we're specifying which service account for a permissions point of view. I'm going to apply this configuration live. While that's deploying, maybe we'll jump back and talk a little bit about the architecture of our application. It'll take a minute for that service to provision. Can we go back to the slides for a second, please? Really, the heart of our demo is going to be using Vertex AI to interpret video frames. In this example, we chose to use Gemini Flash 2.5. That's not a cutting-edge model, but we found it provides a good balance of accuracy, latency, and cost for our use case. Vertex being fully managed is a great way to experiment for your specific use case with different types of models. Neither Elo or I are prompt engineers in any way, shape, or form, so we partnered with Gemini to help us write an English language prompt that encapsulated what we wanted to do. As you can see, we're asking Gemini to be an industrial safety inspector. And it's very important to us that we be able to distinguish between a hard hat and other types of hats. Obviously, if you've got a hood or a baseball cap on, that's not really going to help you in a construction site. This is the overall architecture of the application. It's really very straightforward. What we're going to be doing is taking image data from our client application, passing it into that GKE cluster, doing a little bit of transformation, and sending it off to Gemini via the Vertex service. Our code is pulled from a private artifact registry, so any changes to our application code will be kept and subject to the same set of controls as everything else in the project. And Cloud IAM obviously underpins all of the access to this application. All right, let's jump back to the laptop and see if our application is deployed. All right, looks like we have the service up. So what I'm going to do is, all right, this is a quick front-end test harness that we put together with Gemini. I'm going to give it some test data. Let's start with this test image. Takes a second or two. You can see down at the bottom, it has correctly identified this person as wearing PPE, specifically a hard hat. Let's do a negative test case. This person looks like he might be related to me. He's really not. Let's see. No hard hat detected. And in addition, because we've prompted Gemini, it can distinguish between different types of hats. So that was cool. They worked pretty well. Not bad from a responsiveness point of view. But this is just test data.
Yeah.
That's not as impressive as, will it work in real life? Wish me luck. We're going to give it a second. Does that deserve a round of applause? Hey, Elo, what's up with the hat, man?
Well, I may have run into Sean White at some point. I don't know if he approved this. We were just trading some big air tricks and things like that, Simon. But maybe we take a look and see what Gemini thinks of this. Give it a second. Or a little longer. You can only smile so long. Maybe I need to go closer.
Oh, man.
We're getting some unscheduled learning here. Oh.
Let's hit refresh on that.
Okay. Now, Gemini may not have approved that one, but I happen to have something else that might be useful on a construction site. We'll take a look and see how this. There we go.
All right.
Oh, gosh.
Excellent. Thank you, Elo. Thank you to the demo gods for smiling on us. Could we jump back to the slides, please? All right. So it was a fun little use case, but hopefully that we have shown you how to build services quickly while also meeting your data security and compliance obligations. Custom org policies, assured workloads, data boundaries. Give your teams a well-lit path to comply with unique policies and best practices for your organization. We picked a goofy demo, but the ability to work across GCP services has many applications. For example, in retail, you could use a similar approach to detect stock levels. In banking, a similar approach could be used to detect whether scanned documents are legible. We picked a visual demo, a little bit more interesting that way. But Gemini, being a multimodal model, can obviously summarize other sorts of data. Could be ingesting logging and performance data from your application to preempt performance issues. This architecture is pretty extensible. As Elo mentioned, we've provided a collab, which is a step-by-step guide to recreate the demo that we've provided here. But you can also work with Gemini to adapt it to your use case. Not everyone needs AI for every use case, so if you wanted to adapt it to reach into a data store, if you're working with BigQuery, you can use that as a template. We've touched on many, many topics during this session. We wanted to highlight a few of the sessions earlier in the week that go deeper into some of the things that we mentioned. If you're interested in the AI innovations, there's a couple of breakouts here I recommend. Day 2 operations for GKE is a perennially important topic. There's a great deep dive on that. And there are other sessions that go deeper into the controls. We really touched the surface of the controls in this session, but we really think there's a couple of other sessions here that would be of interest. Elo, you're on the deep dive side. What would you recommend?
If you're curious about things like myself, we're offering or recommending a couple of deep dive sessions there for you to take a look at.
Excellent, thank you. One last slide and an ask from us. We know that you've seen customer session feedback requests all week. These are really important to us. Elo and I read every single one. For the folks who came last year, one of the things we heard from you is bring us more hardware and show us a more complex multi-service demo. So we hope we've delivered on that. We want to hear from you. That feedback is critically important to us, not just to shape this session, but shape the things that we're investing in moving forward. Thank you all for your time. Elo, Jason, and I are around for questions afterwards. We'd be happy to meet and chat. Thank you all, and have a good rest of your day.
Simon?